This next section then looks at where did our solar system come from. Our solar system is just made up of the sun and all the things that orbit around it, so the planets and everything else. But really, it's the same system that forms all the other stars out there. So there's nothing that special about our star, the sun. And you can watch this little video here, and it just shows you the different sizes of stars that there is out there. In our galaxy alone, there's about 100 billion stars, which mean there should also be 100 billion solar systems. And they start off as something that looks like this. Okay, this is a nebula. A nebula is just a vast cloud of gas, and by vast I mean it would extend way, way beyond our solar system does now. And it's mainly hydrogen gas, maybe little bits of helium and some of the other lighter elements. But it won't be uniform, and there'll be a center of mass to that. And because the gas itself has mass, gravity acts upon it. And what gravity will do is it will slowly, over thousands and thousands and thousands of years, pull it closer and closer and closer together. So gravity, as always, is the thing that makes things happen in space. And what you get is, in physics, whenever anything is compressed, it gets warmer. So if you think about it, this stuff is falling towards the center. It's losing gravitational potential energy and gaining kinetic energy. So the particles of the gas will be moving faster and faster and faster. And eventually what you get forming at the center is just a ball of hydrogen gas that is quite warm and warm enough to glow kind of red hot. And we would call that a protostar. It's a little bit like a prototype for a star, so a protostar. It's not a star yet because it's not hot enough. And what happens is gravity continues to pull that together. It gets more and more compressed, and as it gets more and more compressed, it heats up, it heats up, it heats up, and eventually then you get to the stage where at the center of that ball, the temperature is high enough that nuclear fusion can happen. Okay, and at that point then it just turns on like a light bulb. Okay, and it begins emitting huge amounts of heat and light. So it then becomes star, or what we would call, and we'll look into it later, a main sequence star. And it's really that point that our star is born. But something else happens as part of that process as well. In the same way that if you fill a sink with water and pull out the plug, the water goes down the plug hole. But if you actually look at it closely, because of the little discontinuities, because it's not uniform, the water will actually swirl around as it gets pulled towards the center. And the same happens here. So if we look at our sun now, it's actually spinning about once every 11 days on its own axis. But all the material that made that up swirled as it was pulled in, and some little bits get left behind. And what happens is those little bits clump together to form tiny little pebbles. The tiny little pebbles clump together to form stones. The stones clump together to form boulders, and the boulders clump together to form bigger boulders. The bigger boulders clump together, and that process continues until you get planets. And that process is called accretion, and it is a key word and one that you definitely want to learn off as part of this process. So we start off with a nebula. Gravity acts, pulls things together. They heat up. We form a protostar. Gravity continues to act. It gets warmer and warmer. Nuclear fusion happens, and the star turns on. Bits and pieces are left behind. They clump together in a process called accretion, and it's them that form the planets. Okay, and that's our theory about where our star and our solar system and all other stars come from. Now, we have evidence for this. One of the best pieces of evidence is all the planets orbit the same way around the sun. Okay, that's not by chance, it's because they all came from that swirling cloud that swirled in a particular direction. The other thing is our star, the sun, acts as we would expect a ball of hydrogen gas to act with nuclear fusion happening in its core. And we can also observe this stage, or this process at different stages in different parts of our universe. So we can look at protostars being formed. We can look at the disk of debris that's left behind that will go on to form planets. So we have lots of evidence that supports this nebula theory for our star, the sun. We're now going to look at what happens during a star's lifetime.